guys, it's Free from the Gamersphere Network. Coding Tricks video. We are going to integration, and we're going to be doing that through calculating the area. So I went ahead and made a new project. I copied the main.cpp file, and I deleted everything last time except for the for loop. And I copied over two constants. I have up here constant 2 pi and the constant. You can just type in 4 pi or 2 pi into Google, and it'll spit out the exact. Go ahead and do that, and I'll give you a second to do that. But before we begin calculating the area, we need to make a guess about what to expect the answer to be. So we can sort of do that by looking at two squares. That's the inscribed square and the circle. From just the knowledge of the radius, just being some arbitrary value r, we can calculate what the area is. And if the radius of the circle is r, diameter is double that, which is 2r. And then in order to get the length of the side of the Pythagoras, that gives us 2r over the square root. And then we take that value and we square it. Square that, get 2r. That's our minimum value. So for r was 1, then the area. Then for the circumscribed square, we do the same process. Know that the diameter is 2r. So since the diameter is 2r, the length side of the square will be 2. Get the area by squaring that, 4r squared. Radius of the circle is 1, yet again. Area of the red square. So that sort of gives us an upper and lower limit on what the area of the circle can be. So just averaging of values give us 1, and we get 4. That's the value we should expect. And we're going to be doing this by calculating the area of inside a polygon. We can do this pretty easily because as we create this inside a polygon, each triangle is going to be isosceles triangle, and they're all going to be the same. It's going to be pretty easy to calculate. So from just a normal triangle, we know that the area equation at the top right here, and this is basically calculated by taking the vectors of a and b and a. Then you take the cross product, and it's the area of a polygon parallelogram. This would cross product create a parallelogram, and then we need to actually divide this value by 2. Take its absolute value. Actually, adjust this. To do that, I'll absolute divide this. Once again, this equation here is derived from calculating the vector BA and CA, taking their cross product with parallelogram. Okay, then you divide by 2. Triangle. This is in 2 dimensions. So from this simple equation, we can then apply this for how many sides there are. That'll give us the polygon. So the first thing we need to do is we need to actually create a function that implements that equation. Go ahead and make. We're going to create a new function. It's going to return float value. And we're going to call it calculate. And then we're going to bring in some values here. X, Y, X, Y. We're going to take in the different values. We need the x and y values for all three vertices. I'm going to take these in, and then we're just going to return the value of the equation. So we need to take the absolute value, back and look. Line is ax times by minus x y add to that dx times cy minus cy minus c times ay minus. Then we'll go ahead and get the absolute value, and we'll divide by 2. That's going to be the answer. Result of the function, which calculates the area of a single triangle. And then we're actually going to get into it, build the actual polygon. First thing that we need is we need to know how many sides the polygon. I'm actually going to do this interesting way. Let's define what max size is. Also find the rate constant. Two values here. And then we're going to have k start at 4. We're actually going to start at a square here. I'm going to calculate what is the area of the described square. I'm going to do that. Start at 4 side. Go to max. Less than or equal to. And then we're going to keep incrementing k until we get to the polygon with very many sides, very approximate. And now that we have those two things out of the way, now we can actually the root of it. So we need to create our values and define our vertices. These values will always be zero. A is always going to be. Then we're going to draw a triangle. So A will always be 0, 0. Find this. Then we need dx. Call this 0. Y x. Oh. With this defined, we need to get now we need to get additional. So A represents the number of sides for the current polygon, and we need to actually determine how many radians we need to move between the point C and the point. That's determined by the number. Call this 1 radian. Will be equal to constant 2 pi divided by 2 radians. 4 pi. And this is how we're going to calculate B and our C. So to calculate our B and our C, we're going to take our radius, times it by the sine function of 1 radian. Copy that, paste it, and then we're going to change the cosine. So now our bx value is radius times the sine of basically a degree or a radian, calling it one side. Then we also have by, and it's radius times cosine. And this gives us our values for where the vertices are placed on the perimeter of the circle. Right here. That's what we're doing, placing b and the c down, calculating the value, times it by the number of sides we have for our polygon. Actually, now that we have bx, let's get our cx. This is going to be exactly the same what we just had for bx, change it to 2 radians. Now that we have our b and our c, we already know a is 0. We can actually get the area of the circle now. Is equal to k, which tells us how many sides or polygons, times calculate the area of a single triangle. Do that by feeding in y, dx, dy, dx, y. That's it. So now, a couple lines of code here. We have a for loop, which is going to, at each step, it's going to increase the size of the polygon by 1, and we're going to get closer and closer to this area of the circle. At the beginning, it won't be very accurate, but as we increase the number of sides, we'll get more and more accurate. It's going to approximate. I'm going to go ahead and do that, and let's just run that, see what we get. Go ahead and hit file. Okay, so, oh, we didn't print anything out, so it just ran and then stopped. We need to print out the value. Go ahead and do that. Go ahead and tell the user what k value, know how many sides we have. Then tell them what the total area. Call this area of polygon. Polygon. Get a new line. Go ahead and run that. Oh, I missed it. Okay, so here's our output, going from a k of 4 to a k of 10. And when n equals 4, we should be looking at the inscribed square, this blue one here, got four-sided polygon here created. And our value should be 2. What is our output? It is 2. Correct. Have everything. And then as we increase the sides of the polygon, we're getting more and more area. Actual, see from the illustration here, when we start with 3, we're missing a lot of this. Missing this area here. As we increase the sides, that area becomes smaller and this is sort of what I would call sort of a good analogy for integration. Integration deals with approximating area of a curve or a function. You do that by making the area of each individual piece smaller and smaller and smaller. And if you can imagine the number of sides of the polygon getting larger and larger and larger, tens, hundreds, thousands, then the area of triangles is very small, closer and closer to approximating real area of whatever the function is. It just happens to be that we're doing a circle. Let's go back to our function. Let's increase the number of sides here. Let's go from doing 10, let's go to 100. So now we're going to be 100-sided polygon. And we can see just from the output that as we increase the sides, we're getting closer and closer to approximate the total area of the circle. Keep in mind that the radius is 1. And we know from our basic schooling in mathematics, the area of a circle is pi r squared. I mean, drilled into you. Pi r squared is the circle. So if our radius is 1, then total area of the circle, which is pi times 1 squared, which is pi. Pi is roughly 3.4. As we're increasing the sides of this polygon, getting closer and closer to approximate. We can increase this to even more. We did 100. But instead of printing out all the values, 1,000, I'm going to add an if statement. Say if k is greater than max size minus a value called print last, I'm going to go ahead and print it out. We can come up here and declare a new variable, find it, print last 10. So basically what this does is it's going to print out the last 10 value. So we're not printing out 1,000. We'll do that, and here you can see the results. And you notice that as we get further and further along the number of sides, we're starting to get to a point where we can't even tell that the approximation is rounding. So all these values are identical. Let's actually see we're at 3.1415. And this actually allows us to see that we're continuing to. So that's the video for this time. I just wanted to kind of illustrate the whole process of sort of creating a first program where you have a function, using that function quite often, calculating some variables. But I also wanted to do something sort of math or that's why I chose to do the area. I hope you enjoyed the video, and I hope you sort of understand the process, taking basically infinite number of small things and adding them up to get the true value of whatever the curve be. So stay tuned for more great videos. Liked what you